This lesson, we're going to be looking at the patterns. We're going to be looking at exploring patterns and see how they're growing and see what's happening with each of these patterns. And so let's go ahead and I want you to look at the warm-up. What would you have done to get from the fourth design? So each time they're adding another row on the bottom. And so when they add that next row, it's going to be a pattern of 1, 2, 3, 4. Each time the next row is being one more than the previous row. That is an observable pattern. So let's look at the cupboard and bees. You can find patterns everywhere. And so we can look for the size, the shape, the texture. Sometimes it's about the aesthetics of it. Sometimes we're actually looking at a pattern of how the numbers grow. And so in this case, we're going to be looking at a beehive. Let's consider a family tree of a male bee. Female bees have 2 parents, a male and a female, whereas male bees just have 1 parent, a female. In this family tree, the parents appear below are the original male bee. So let's look at creating this pattern. So the number of bees in the first generation is 1. And then the next generation is 1. Now we have 2 in the third generation. Then we have 3 in the fourth generation. And then in the 5th generation, we had 5. And then in the 6th generation, we have 8. So what pattern can we see that can help us create the mathematical pattern of what's happening here? And so, by the way, this is the answer to number A. If we were to keep this pattern going, we want to figure out what the next 3 are. But we first have to figure out the pattern. So these 2 add up to create the 2. These 2 add to create 3. These 2 add to create 5. These 2 add to create the 8. So 5 plus 8 is 13. And so I'm going to take 8 plus 13, and that's going to give me 21, and that's my next. So far, we've got 13, and that's in the 7th. The 8th is going to be 21. And then to get to the 9th generation, take 13 and 21, and that's what we add together to get it. And so we have 34. This pattern, where you take the previous 2 numbers and add them together to create the next, is what's called the Fibonacci sequence. And in Algebra 1, we talked about there's 2 different types of rules we can create. We can create a rule based upon just identifying the pattern, or we can create a rule like we normally do, where it's you're looking for the 9th generation, so you type in a 9 and you get the answer. And so let's go ahead and find what is called the recursive formula, which is just saying, okay, what did I do? Well, for the nth generation, I took the previous 2 numbers and added them. So what this is saying is, in this case, if I'm trying to find that 7th term, n minus 2 means I go 2 units 2 times back. So I get the 5. Plus the n minus 1, which is the 1 time back, which is the 8. So I take those two numbers, add them together, and I get my 13. But we typically like to have things where we can actually just plug it in, and that's called the explicit. So this is the recursive. And the explicit just says I can take and plug in and come up with a formula. The Fibonacci explicit is a more complicated formula. It is 1 plus the square root of 5 to the nth power minus 1 minus the square root of 5 to that nth power, all divided by 2 times 2 to the nth power times the square root of 5. And so that's the explicit. So like if I'm trying to find the 8th, I plug in an 8 for my n's, and that gives me my answer. And so let's look at Miriam. She owns a flooring company. This is on activity 1-1. Her last job involved tiling a square room. So square room means each side and length are the same. And the customer, Mr. Riviera, requested a tile pattern alternating black, then a white row, and then a gray row. And then so the next one in this pattern is going to have a black row, as the shown here. Each tile represents 1 square foot. So if I was to go out to the next pattern, so if I want to go one more row out, I'm going to have a lot of, I'm going to end up with black going around. And so right here we have 1, 2, 3, 4, 5. This one we had 3, and this one we had 1. So for the first one, our side was 1, and then we went to 3, and then we went to 5. The number of new tiles added each time. So this is the side. We can also think about how many new tiles are added. So to get from design 1, so design 1, we had 1, and then the next one, to get to the next one, we add 3, 4, 5, 6, 7, 8. 8 new tiles. This next one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So 16. So this is if we're, how many tiles are we adding each time? But if I wanted to actually think about the total number, so this is just taking and analyzing. We're analyzing that tile pattern. So we can be looking at it from just looking at the side perspective. We can look at it how many we're adding each time. And then we can look at the total number of tiles. Well, to get the total number of tiles, we're going to take that 1 and we're going to square it. And we're going to take that 3 and we're going to square it. And we're going to take that 5 and we're going to square it. The next one will be 7 and then squared. So we are going to be looking for one of these patterns. So for the sides, we're just counting up the odd numbers. So we're basically adding 2 each time. And ignore the first one because that's not really going to be part of the pattern. So we add 8. We're going to add 8 each time. So the next one would be 24. Then we'd add 8 again to get 32. So when we're just looking at the number of tiles we're adding and the total number of tiles, we can take our side length and square it. So 1, 9, 25, 70, 49. And so if we're looking at it for it to be a 9 by 9, so we've gone up to a 5. The next one's going to be 7. Next one's going to be 9. So we're looking at 2 past what we have here. We're looking at design 5. Let's go ahead and sketch what the design is going to be. And so that means this is going to be our black row. Or see. No, let me go back. So if we go to the center, it's black. Then we went white. Then we went gray. Then black. Then white. And so you're going to have, this is an entire thing of white all the way around. And so forth with each of these. And so white is our outermost color right now. And hotel manager wants Miriam to tile their lobby using the same design she created for Mr. Riviera. The lobby measures 45 feet by 45 feet. He wants the outer edge to be the same color as the center tile. Will this happen? Justify your answer. And so, if I was to try to come up with a rule, and so we need to figure out, if I want to come up with a rule, how can I go from what side I'm in to find out the design number? So, for design 1, I was had 1 for my side. For design 2, I had 3. Design 3 was 5. Design 4 was 7. Design number 5 is 9. And this keeps going. But we're trying to figure out, what design number am I going to be at when I'm at 45? What is that number? So how can I take, and this is my n, to come up with what number I have here? Well, if we're trying to come up with this rule, we talked about that it's 2. We're adding 2 each time, so 2n. So let's look at 2. 2 times 2 is 4. Now if I have minus 1, will it give me 3? Yes. 2 times 3 is 6. Subtract 1, does that give me 5? Yes. So my pattern that I'm repeating is 2n minus 1. So if I want to take that pattern, 2n minus 1 is going to give me what number in the pattern I'm in, but it will give me my side length. So if I add 1 to both sides, 2n is equal to 46. Divide by 2 gives me n is equal to 23. And so we're 23rd number in the pattern. So if I determine that the outer edge is 20, so we're looking at 23 out. So I would need to have it be in the pattern black, white, gray, it would actually end up being the white. If you were actually to go out and count it out, black, white, gray, black, white, gray, and keep going, because we know we have, this is 3, 3, 3. So to get the full way through the pattern, you need a set of 3. So 3 of these. So we get a full set of 3. That's going to get us down to, there'll be 7 full sets. And then that would be 21. And then we start with the 22 and 23 would be put us at that white. So if you're having trouble trying to see how I got there, that's how you can see it. So then we have a very picky Paula Perkins. I want you to stop and I want you to think about how you can, they're wanting to alternate the black, white, gray again. But she wants an outer edge to match her wall color, which happens to be white. What color must she start at in order for this to happen? So our goal is to end on white. And she has 101 steps in it. So we want to end 101 feet in it. We want to end on white. So you should have found out that 51 is the number in the pattern I'm at, but we want to end on white. So if I want to go backwards from white, the one right before white would be black, and the one before that is gray. And so I want to take away full sets of 3 and then see how much I have left. So I'm starting off with that 51, and this time we're actually going to be going backwards by subtracting sets of 3. So how many sets of 3 do I have in that 51? So I have 7 full sets. And so therefore, to have a full set, what I would start on is gray. Because 51 divided by 3 is 7. That means I'm going to be going through the pattern 7 full times. So in order for me to end up with white as the end, I must start on gray. And again, if you wanted to, you could actually go back and go, I have white, go back 51 of those numbers and see which one it is. So let's look at this next one. We're reasoning with the patterns. So the class president, vice president, and treasurer of a high school count the ballots of the homecoming king elections. The results are generally kept secret until the pep rally when the winner is announced in front of the entire class. Unfortunately, this year's ballot counters are not very good at keeping a secret. The very next day, after counting the ballots, the counter tells 2 of their friends in the senior class their election results, making each friend vow not to spread the result. However, each ballot counter's friend cannot keep the secret either. Each friend shares the election results with 2 of their friends in the senior class. This pattern continues for an entire week leading up to the pep rally. So let's actually just kind of go through it. And let's make a visualization of this pattern. So on day 1, number of new seniors that know, and then the total. So the new seniors that know are 3, because we started off the day 1, 3 people discover it. And the total number of seniors that know are 3. Day 2 rolls around. Each of these people, the new ones, told 2 people. So that means day 2, we have 6 people that knew. Or that found out that day. And so that means there's a total of 9. On day 3, there is 6 seniors that knew the day before. They tell 2 friends. That makes it at 12. 12 plus 9 is going to give us 21. I want you to finish filling in this pattern. So if this pattern continues for an entire week, on that 7th day, 192 new students will have found out about it. And that will bring our grand total up to 381. How many new seniors will know the winner of the Homecoming King election on the 4th day? Well, on the 4th day, if we look at our pattern, that's 24. And the total number in the senior class is 250. How long will it be before the entire winning class is actually going to know the election results? And so we're at 189 on day 6, right? And this is going with question number 3, by the way. And so on the 7th day, we will, on the 6 days later, we're going to be at 189. So on the 7th day, if we were to actually go farther out, then you would actually get there. So on the 6th day, not everybody would know. There would still be 61 that don't know. Because on the 6th day, it was 189. And so this is all using that table to help us figure out our pattern. And so we're going to look at Maureen and Matthew. They're going to design a backyard patio. There's going to be an entrance and exit, and then the patio in the middle. These are some different designs depending on the size of the patio they want to represent. And so this one has a 1-row depth. And so we have our pattern. We're going to increase the number of rows. So let's first look at the rows. How many rows do I have on that first design? So on design 1, we have 3 rows. On design 2, I have 4 rows. 1, 2, 3, 4. On design 3, I have 5 rows. 1, 2, 3, 4, 5. And we can keep going with that pattern. So what that pattern is saying is we're adding 1 more row each time. So let's look at it another way. And so we're basically looking to see how many different patterns can we come up with. So the number of squares each row in the patio increases by. So here we're looking at the design and squares. On design 1, we have 3 plus 2, 5 squares. On design 2, we have 1, 2, 3, 4, so 8 plus 2, 10 squares. On design 3, we have 1, 2, 3, 4, 5, so 5 times 3, 15, plus that 2, 17. So what are we increasing the number of squares by each time? So we added 5 here. We added 7 here. So what do we think we're going to add to the next one? 9. And so the next one is going to be 26 on design 4. And so there's a lot of different types of ways you can think about how are we increasing the number each time. So let's kind of design 6. So that means if I keep going this pattern, how many rows are we going to have? 4, 5, 6. We're going to have 6, 7, 8 rows. So let's count out 8 rows. 1, 2, 3, 4, 5, 6, 7, 8. And so I know I'm going to have an entrance, and then I go down 7. And if I look at this, this was the number here. In the middle of these two, we have basically a square each time. So here I know I went down, I had 5, so I need to go over 1, 2, 3, 1, 2, 3, 4, 5. And then I draw it down. But I also need to consider the fact that I need an exit. And then, oops, that was the 5. I forgot to do the one more row. Okay, so that's the design for the 6th one. We're going to have 8 rows in that 6th design. And so design 3 has a 2 by 2 in this, or just has a 3 by 3 in the center. Design 6 should have a 6 by 6 in the center. Is it design 2, design 1? Did I do a 6 by 6 in the center? Oops, I think I just got 5. 1, 2, 3, 4. It's one more row over. So is that 6 by 6? 1, 2, 3, 6. Yeah, now I have a square in the center. Sorry about that. So you'll end up with the number of columns. If we kind of looked at the columns here, we had 3 columns, then we had 4, and we had 5. So it's just the same thing as the rows. And so this is actually going to end up being a square, that final design. So if he had 170 tiles to use for this project, what is the largest patio design he could actually make? And so let's think that through. Let's find out, what can I do to figure out the largest design that we can make? And so if we look at the way it was designed each time, so think about how I was showing you how I did these numbers down here. What I did was I did 2 times 4. This was 3 times 5. So if I was to look at going out further, we can try to go, okay, we have 170 tiles. Let's go ahead and take off 2 of those, because we always had those entrance and exits. So that's going to be 168. And I want to figure out what design would actually get us a total of that 170. And so I need to find 2 numbers that are 2 apart. Then multiply to give me 168. And so you can kind of go through it and see. So 10 and 12 will give me 120. 11 and 13 gives me 143. And so I keep getting there closer, and if you keep following that pattern, you will get. So if we kind of keep this pattern going, at 12, we'll be multiplying it times 14. And 12 times 14 is 168. And so that's the number, and that 12 corresponded to the design number. So it would be the design number 12 that would actually give us the largest patio design. And so for design 12, that meant that you had 12 rows in that center part plus your entrance and exit. So 12 here.